Good afternoon, everybody, and welcome to ESOA's showcase session on enabling the agri-tech revolution. I'm joined today, next slide please. I'm joined today by my colleagues, Stephen Tompkins, who is Director of Agriculture and Rail at Inmarsat, and Mikhail Kaigorodov, who is Commercial Director for Russia from OneWeb. Together, we're going to be talking to you about what satellite communications does for agriculture and how vital this is for the CIS region. Next slide. Before we start, I would just like to introduce you to our members. ESOA represents 21 satellite operators, which are both global and regional companies offering satellite communication services around the world. So without further ado, I'm going to pass over to Mikhail, who's going to talk to you about the role of satellites for agriculture. Mikhail, the floor is yours. Next slide.
Thank you, Aarti. Hello, everyone. Let me start the introduction in our unusual maybe topic, but very important for CIS countries because this region has a good opportunity to increase the food, and I think we will talk about some aspects how we can use the satellites for digitalization in agriculture. So, according to the data of the Ministry of Agriculture, at the end of 2019, 120 million tons of grain were harvested in Russia, including 75 million tons of wheat. In 2020, the figures increased by 10 million tons, but production can be higher. According to the Analytical Center of the Ministry of Agriculture and McKinsey, about 40% of the crop is lost in production at various stages. Increasing yields and production efficiency requires a large-scale task of increasing agricultural exports. According to the decree of the President of Russia, by 2024, agricultural exports should almost double to $45 billion. And today, farmers face the question, please next slide, how to harvest more crops from 1 hectare and spend less resources, both human and material, on it. More than an effective solution to this problem is the digitalization of agriculture. Let's compare. In traditional agriculture, a high dependence on the human factor is clearly expressed. There are factors such as a relatively low yield at the relatively high production cost. As a rule, success pricing environmental is a factor of success. In digital farming, there's a clear focus on the efficiency of each operation. Digitalized agricultural machinery, sensors, drones, and other digital elements help to achieve this. At the same time, the management of production processes is automated. The production demonstrates a relatively high yield at the relatively low cost. The introduction of technologies for the growth of the agro-industrial complex has already become the task of the digital agriculture project developed by the Ministry of Agriculture of Russian Federation. The same project was started from other CIS countries, and we have in CIS the committee, agricultural committee, and this is the place where we discuss plans to increase results from agricultural complex in CIS countries. And this project and the same project in CIS is designed for 2019-2024 and includes several directions. Thank you for this slide. No. Please, one slide. Yeah, thank you. Adoption in CIS, TATE has lagged other countries. However, the abundance of very large agribusinesses and further consolidation in the industry, the general move towards less farm that are much bigger, make the value proposition for these technologies more compelling. We will land in CIS regions, and adoption will be critical to maintain competitiveness of the sector against other regions. While the leading countries of the market, such as USA, Australia, Japan, are actively introducing digital technologies in agri-industrial complex, robotizing production and improving the use of big data, Russian agricultural companies consider it a priority to introduce new capacities, reduce costs, and increase production. The same situation we see in other CIS countries also. Digital technologies have been introduced today in less than 5% of Russian farms. Agricultural holdings that are among the top 30 largest farms studying digitalizations. We are trying to understand the economic impact of precision farming and digitalization for all stages, from plowing to harvesting. But even large agricultural holdings, whose land bank exceed more than 300 million hectares, have digital technologies implemented only in some farms. The good news is that the volume of the Russian market of information and computer technologies in agriculture in 2019 reached 360 billion rubles, according to the Ministry of Agriculture of Russian Federation. According to the ministry forecasts, this indicator will increase at least 5 times by 2026. The same forecast we have about other CIS countries, for example, Kazakhstan and other players. This means that precision farming technologies will be used on every farm in the foreseeable future. Please, next slide. Thank you. Thus, the path or vector of digitalization in the agro-industrial complex can be represented in the form of 3 steps, of three stages for agricultural holdings, and 2 steps without the last one for relatively small agricultural producers. The first stage characterized an agricultural company with efficient business processes. Both fully integrated internal accounting systems and a single digital back office should be implemented here. Both dashboarding, a dashboard reflecting the values of the most important business indicators in real time, and the accumulation of a database of production performance indicators should be used. The second stage of development is already a digital technology company. It uses innovative technologies such as precision farming, artificial intelligence, computer vision, machine learning, etc. Supply chains in such a production are built online. Sales are omni-channels, both offline and online, whereas innovations are constantly being introduced. The third stage is the ecosystem of the agricultural holding. A whole infrastructure of innovations has already been built here. Market participants are integrated into a single system based on the digital platform of the agricultural holding. And the sale of digital solutions or services in the Agri industrial complex exists as a separate business. To achieve an increase in business profitability, it is highly desirable for agricultural enterprises to fully master the second stage of the path. For real leadership in the industry in 7-10 years, one should strive to enter the third step. But right now, we know that many CIS agricultural companies are faced with the tasks of the first two stages of development. Last slide, please. And I would say that connectivity is a big barrier to digital development in agriculture. Many of the use cases require individual devices reporting in very rural areas far away from urban, where there is no reliable terrestrial networks. Erecting private infrastructure is an option, but it is very cost intensive. You wouldn't spend $100,000 erecting a cellular mast to monitor a couple of water tanks. I think it's obvious. Satellite is the most cost-effective way to fill the gaps, and its ability to OPEX the cost means AgTech providers can build it into their monthly recurring fees. Satellite technologies can play a key role here, both for the implementation of government development programs and purely commercial initiatives. And here we can use both satellites in geostationary orbits, which will provide connectivity for applications that do not require signal delays and connection speed, such as collecting data from various sensors and new generations of low Earth orbit systems for transmitting heavy content like broadcasting and etc. in real time at high speed with low delays. It's important to know that Russia is a key example of a country in the CIS. Demographically, large-scale farms dominate. 90% of the land belongs to large agribusinesses. On large farm, the value proposition for AgTech IoT is most compelling, as this technology reduces the needs to travel long distance to manually monitor fields and infrastructure. But also, the connectivity issue is likely to be more serious and obstacle to adoption, which is why satellite has such a crucial role. Satellite solutions are quite diverse and can satisfy many needs of users of the agricultural industry. As a conclusion, I will give just one example of the practical use of satellite technology, and my colleague Steve continue it on next presentation. One of the largest Russian agricultural holdings, Cherkizova, uses satellite tracking systems on its farms. We provide weather reports, allow you to monitor the state of crops and track the entire agricultural cycle. Agricultural holdings are not yet massively introducing unmanned technologies. First, the use of drones is not yet regulated by law. And secondly, drones in comparison with satellites are less effective since we have limitations in use associated with flight duration, time of day and weather conditions, and to assess the state of field in large agricultural holdings, using drones is too much, a lot of time. According to estimates, the introduction of satellite field monitoring technology can cost an average farm about 1 million rubles a year. this is all I want to say. And thank you for your time and for your attention.
Thank you, Mikhail. Thanks for that interesting presentation. I know that Russia has a target of $45 billion of food exports by 2024. And
Right.
this kind of technology is going to be vital to help achieving Russia and other CIS countries make that kind of step. Okay, I would invite participants, before we go to Stephen's presentation, I would like to invite participants to please share their questions in the chat. And we will also be sharing a link to our brochure on satellite communications for agriculture, which you can read more about. So thanks, Mikhail. Now let's go to Stephen Tompkins. Stephen, you work for Inmarsat, and I know that Inmarsat has a history of enabling connectivity for various different types of agriculture services and applications. Let's hear something about them. The floor is yours.
Great, thank you, Aarti, and thank you for that introduction, Mikhail. What I'm going to try and do is pick up on some of the points that Mikhail talked about and give you some real live case studies of what's happening today enabled by satellite in the agriculture sector. Slide, please. So I've got 3 slides of case studies for you here. The first group is all around saving time, fuel and emissions by controlling farm infrastructure in real time remotely and monitoring fields automatically. So if we go to the first case study on the left here, the water monitoring solution, this comes from rural Australia today. So probably as we speak at the moment, there are 10,000 farmers driving around rural Australia manually checking their water tanks to make sure there is enough water for their livestock. And this is hugely time consuming, takes a lot of fuel and has all the consequent carbon emissions. And we've been working with a small company that's produced a water tank monitoring system. It's simply put on top of the tank. It monitors the level of the water in real time, and it also helps to control the infrastructure. So immediately there's a payback to the farmer from not having to travel to these sites, saving thousands of kilometers. And these water tanks are in the middle of nowhere, so they could be hundreds of miles from the nearest settlement. You know, as Mikhail said in his introduction, it just simply is not feasible to put up the terrestrial infrastructure from a cost perspective to support this. So satellite is the natural option here. And that's similar for the other case studies on this page. If I look to the middle, this is soil moisture monitoring, essentially looking at how much water is in the soil to then inform irrigation decisions and how much water to apply to the crop, which is critical for yield and quality. But a lot of these fields are in areas of low connectivity. They also have no power at all. So enabling this system by satellite makes sense. You can simply drop the unit that I've got the picture of in the middle of the screen here into the middle of a field. It has a solar panel, it has satellite, and it also has a long range network to pick up those individual sensors and send the data from A to B. And the example is similar to the one on the right hand side, which is more about monitoring the irrigation system itself and checking if there is any blockages or how quickly the system is moving, all saving the farmer have to go to the field to do that manually. Next slide, please. Slide, please. Thank you. So then the next set of case studies is all around vehicular applications, and farm machinery is a big focus for the onset of agricultural technology. There's lots going on in this space, and actually satellite has a really strong heritage in this sector already. So one of the initial agri-tech innovations that was introduced to the industry, probably coming on for 10 years now, is precision guidance systems, which is shown on the green tractor on the left-hand side on this slide. And that essentially enables the tractor to operate the machinery and steer the machinery automatically. And why would they want to do that? Well, they want to do that because they want the machine to stay on exactly the same point in the field every time it comes into that field to minimize the damage to the soil, and also to accurately apply all the inputs like pesticides, fertilizer, etc. But They would use GPS technology for this, but GPS is generally inaccurate for this application. You need to get down to within 2 to 3 centimeters accuracy. So geostationary satellites, as we speak right now, are probably enabling 60,000 machines worldwide to precisely automate that signal by referencing to a ground station and getting it to within 2 to 3 centimeters. We're also seeing that there are higher bandwidth applications for this, sending data directly from tractors to the operations center to enable precision farming applications and process automation, all about improving efficiency and spending less on your inputs, which is very relevant when you're running a very large farming operation. If I go over to the right-hand side of this screen, this is all around predictive maintenance. This example comes from Brazil, very similar context to CIS region, where you have very large agribusinesses operating over hundreds of thousands of hectares. Within their fleet, they probably have 10 to 12,000 pieces of equipment. And those pieces of equipment are used all day, every day to harvest and plant crops. And the worst thing that can happen when you're doing that is for the machine to break down, because the team that's running that machine is then left doing nothing for hours or days at a time. But there is a solution to this. There is telemetry data, which is produced by the machines themselves, that allows you to see whether there are warning lights, to predict the maintenance. And if we can get that data from the field to the operations centers, that allows them to dispatch engineers in real time, to order parts, to avoid that downtime. But obviously connectivity is a huge issue. In Brazil and in the CIS region, you would not have terrestrial connectivity in all of these places, and you need to somehow cost effectively connect that massive landmass of different fields. And so what we've done here, this uses not just our satellites, but also fixed satellite services as well, to enable these type of trailer-based setups where you're backhauling the data by satellite and also using a long-range network to connect 10 to 12 vehicles at any one time. So a real strong value proposition in efficiency. Slide, please. And then the last set of case studies come a bit further down the supply chain. So once the crop has been taken out of the ground, clearly the last thing you want to happen is for that crop to be destroyed before it reaches the consumer's table. But post-harvest waste and loss is a huge issue in the industry. And we see that happening a lot, but there is real-time monitoring technologies for avoiding that, both in storage and farm and through the supply chain. And given satellites' ubiquitous coverage across land, sea and air, it's perfect for those type of applications. And that reaches the end of my case studies. I think you can see that there are hundreds of applications being used by satellite today, and that applies very well in the CIS region, where you're trying to make efficiencies and ensure competitiveness against other regions for the agriculture sector.
Very good. Thank you so much, Stephen. That was interesting to hear how our technology is actually being used in the field, quite literally. And, you know, you made me think that at the time of the pandemic now, securing the food supply, the importance of local produce, the importance of giving tools to local businesses to increase their competitiveness is all vital, but also global trade. Because while maritime and all of these things are down, we still have ships traversing the oceans with carrying food from one place to the other, because that is essential. And so you make me think how satellite is not just relevant directly to agriculture, but also to global asset tracking, and also even to climate change and environmental monitoring, which is also directly relevant to the agriculture sector. Mikhail, I'd like to ask you first, what bands are satellite operators using to deliver all of these vital services? Where is the big investment going, and what does the future hold in this context?
I think it depends on what we consider to be vital services. Mm-hmm. If we're talking about security and other governmental services, we know that C and L bands are historically occupied by many security-related services. So the future, I think, lies in the KU and KA bands, which have already become traditional. And further, we need to use Q and V bands also for new next generations of satellite constellations, I think.
Thank you. Thank you. We're getting some questions coming in over the chat. How widely are satellites being used in CIS to deliver connectivity to farms already? I don't know if either of you know about that already.
I can pick up. I mean, I think this is a growing need, right? I think the use of agricultural technology in CIS is possibly behind some other regions, but it's growing massively, and we're seeing a lot of the machinery manufacturers investing here. They're seeing the growth opportunities here. The agri-tech companies are investing here, and there are small examples today of satellites being used to enable these types of operations, but it's growing very, very quickly, and we're seeing the need absolutely increase and more demand for those services. So I would say relatively small today, but on a very upwards trajectory, and I think we'll see in the next 1 to 2 years that explodes in kind of our demand for that.
Great, thank you. We then have a question which is made up of multiple little questions, but let's see. So do you see roles for both LEO and GEO satellites in this space? What use cases are most suited for each type? And are you working with the mobile sector on this? It would make sense for the two sectors to collaborate to meet all needs. I can probably talk about mobile collaboration in a bit, but on the initial parts, who would like to take that question?
Please let me answer for this question. Yeah. I think, in fact, it's hard to remember an industry where satellites play no role. Probably a fairly typical example would be the use of satellite connectivity to provide the internet for passengers and aircraft crew. In fact, being in touch during the entire flights is important for many, and the choice of entertainment on a long journey is wider if you have high-speed internet in your device. As you already know, many airlines are already paying close attention to this issue and are equipped aircraft with the necessary equipment, and the CIS cannot be outside this process, since it is a huge land mass over which there are air routes from Europe to Asia. I would also like to remind you about the use of satellites for sea vessels, for remote mining enterprises, the oil and gas sector. A set of examples would not be complete, I try to answer your question, without the use of satellites to create transport networks for mobile operators. And the LEO constellations, which have high-speed connectivity, which can compare with the fiber optic networks, really can be used for backhaul for mobile operator, and we have understanding from mobile operators in Russia and CIS countries that it can be a solution for rural areas, and satellite. This is a good technical solution for that. In general, as we see, the competitiveness of satellites grows as users move away from areas with developed telecommunication infrastructure, where there are many available options to provide a connection with good quality and high speeds, satellite is only one of the solutions, but where the number of such options is limited, and accordingly, expensive satellites is what you need.
Yes, very good. There's one thing you didn't mention, which I think is probably very important, especially for CIS as well, is Arctic connectivity.
Yeah.
When we talk about GEO and LEO, obviously the look angles from LEO are very important, and there is an increasing interest, both scientific and other, in monitoring and communicating with Arctic stations. So, Stephen, would you like to come in on the question?
Yeah, I mean, I can talk, if I give an agriculture example, and I can see that there's also a question on the future agricultural use cases, and I can kind of wrap them into two. I mean, I think if we look at the future of agricultural technology, it's moving towards further automation from behind a laptop or a computer. So farmers will become digital stewards of that information rather than doing stuff in the field. And the future is very much for robotic machinery doing the jobs without operators, taking data from sensors in the soil, from drones in the sky, from multiple other sources. And I think what we're seeing is a role for multiple different satellite types in that space. So you're probably using geostationary satellites to get the sensor data from A to B, and for the highly reliable critical information to keep those machines operating. LEO probably has a very strong place there in terms of the high bandwidth data and using video to automate those machines and taking the drone data autonomously from the drone down to the machine to tell it what to do. So I think there's very much roles for everything in that space, really.
Thank you. Thank you. Okay. I have another question for you, Stephen. When we think about the deployment of these technologies, how does satellite interoperate with a wider 5G network?
Yeah, so I think it's really important that satellite is filling the gaps between terrestrial connectivity and also providing a highly reliable backup. So increasingly, we're seeing that there is a need to interoperate between the different networks. So if you think of a vehicle or a tractor, something like that, that's roaming between 3G, 4G, Wi-Fi, and satellite, there's increasing amounts of technology out there to switch between those different bearers and make sure that you've got the most cost-effective solution for the farmer. And I think it's up to us as a satellite industry to ensure that interoperability as we're a part of that wider ecosystem.
Thank you. And I said I would come back about the collaboration between satellite and mobile. It's worth noting that ESOA is the market representation partner for the satellite industry in 3GPP. And there we have both work items and study items ongoing, both for new radio to support non-terrestrial networks, so satellite, but also in the field of NB-IoT. And that comes back to the global asset tracking, which is very relevant. And I know we're seeing some good developments there. ESOA also has an MOU with NGMN, the Next Generation Mobile Network Operators Alliance. And NGMN has issued a paper on the role that they see for satellite operators in ensuring complete connectivity. They submitted that to 3GPP to support the satellite elements being included in Release 17. So yes, the collaboration between the two sectors is definitely ongoing at a technical level, at a business level, but there needs to be more of it. Another question for you. Other examples from other industries who are using advanced technologies where satellite is playing a role. I know you've touched on this, but Stephen, you know your title also includes rail, and that's probably relevant as well. And I'm sure that Mikhail has plenty of examples as well.
Yeah, sure. So I think particularly in terms of heavy haul freight rail across Russia is something that's actively using satellite today. And we're seeing in that industry, there's a digital revolution happening as well for all kinds of telemetry-based systems and train control systems to ensure greater capacity and efficiency on those lines. And with trains moving in and out of coverage very quickly, they need something very highly reliable in the backbone to ensure that they're always connected. And we see a strong need for satellite in that sector.
Thank you. Mikhail, would you like to comment on that?
If I said before, we know a lot of examples where and areas where we use the satellites. Satellites provide connectivity for aircrafts, for vessels, for rural areas, for enterprises, and for Russia and CIS. It's very important because we live on the huge land mass, and satellites are really important to establish connectivity everywhere where we need.
Thank you. So I have another question for you, which is how accessible, how affordable is this technology for the agriculture ecosystem? I mean, when we think about agriculture, we're talking about agri-tech and big companies on the one hand, all the way to rural farmers who are probably not the wealthiest of people. So the satellite technology, I see that it is crucial. I see that it's transformational, but how accessible is it?
I mean, if I have a shot first, I think a lot of the technologies that we're seeing that are using satellite have a very, very clear value proposition to the end user. So if we take the water monitoring example as a really clear one, you can put that device in the field, and usually within 6 months, the customer has saved enough money on fuel from not traveling to those water tanks to justify the cost of that system. And I think we're seeing that the agri-tech industry is quite smart about the amount of data we're using. So particularly within those systems, they're using kilobytes of data a month. So it becomes very affordable over satellite to make it stick with the overall value proposition. So we're seeing these small technologies that have a really clear return on investment really taking hold in the sector very quickly and paving the way to do cleverer and bigger things later on.
Thank you. Mikhail?
As I said in my presentation, estimates of Russian companies which provide the digital technology based on satellite for Russian farms. For example, the field monitoring technology can cost an average farm about 1 million rubles a year. I think it's not expensive, especially if we will try install the cellular tower on a lot of fields.
Thank you. We have another question from Victor Strelets. Mikhail, let me give you a second to read that. And let me just ask Stephen one more thing. We have done something unusual. We're in a Spectrum conference here, but we're talking about agriculture. But we're talking to regulators and people in the ICT community. What can we do to to bring the technology to farmers?
I think it's about making the technology very accessible to farmers. I mean, for us as a company, our big focus is working with the ag tech community to get satellite working with those devices so it's very well understood to the end user, because a farmer doesn't want to hear about satellite. They don't want to hear about 3G, 4G or any of that. They just want to hear about the end product. And I think as an industry, we're doing a good job partnering with those companies and just making available that resource so these companies can drive their products into the sector is critical.
Thank you. So coming to Victor's question, what steps does ESOA plan to take to develop the ITUR recommendation to standardize the IMT 2020 5G satellite component interface? Mikhail, do you want to take a shot at that?
Good question. Thank you, Mr. Strelets. I know he asked the very interesting questions. I think the main path, the main way is a discussion with a regional organization. If we are talking about CIS, this organization, the main organization which play the important role for this area also is our CC, I mean the Regional Commonwealth and Communication. And the representatives of satellite companies and associations work in the commissions and groups of many regional organizations, and I think we find the right way and steps how we will obtain the right decision for standardization IMT 2020 and 5G satellite component.
I think I would also add that there is so much interest. I think the interest in the NTN work items in 3GPP in the RAN working group has doubled since the satellite operators stepped up and started being more involved there. So, and 3GPP, I know they also send liaison statements to the ITU in order to keep them informed of what's going on there. But we are definitely on track with the normative work items on NR for NTN in the RAN working group. There's also important work going on in, as I said, global asset tracking, so NB-IoT, which will also be relevant as well, especially to the kind of areas that we're talking about: agriculture, environmental monitoring, climate change, asset tracking. All of these things come together very nicely with the developments that are taking place in 3GPP. Anyway, so I think we're almost out of time. Stephen, would you like to make any closing remarks?
No, I don't think so. I mean, you know, this technology is exploding into the sectors, and I think we will see that the CIS region is the next one to be the big thing, because the value proposition, as Mikhail said, for these big businesses, for agri-tech in CIS is so compelling, and it's about making our resources available to them so that the agri-tech industry can be successful in the CIS region and those producers can take advantage of the technology.
Thank you. Mikhail, last word from you?
Yes, I hope we will see a good future for satellites everywhere, in agriculture, in other industries. And CIS, I think it's one of most important area for implementation satellite technology everywhere.
Thank you. So I think I will close by just repeating that digitization is absolutely key for farmers to react, to adapt and survive in an increasingly complex world. Satellite communications can definitely help. I hope that the participants have enjoyed learning about how our sector can help with that. And as regulators and as policymakers who deal with digital technologies, we ask you to remember the role of satellites, recognize how they are growing in importance. In order to bridge the divide that we see, which is not just about broadband for people at home, it's very much also about these kind of industries. And I hope you know that we are investing in KU band, in KA. C band investment is still very much there. And now we're also looking at the Q and V bands as well. So all the way from the lowest, from L, up to the millimeter wave bands, satellite communications is making good use of it. And we thank you so much for having attended. And thanks to Stephen and to Mikhail for your time and for animating this session with me. Thanks, everybody.
Thank you. Thank you.